go to 500,000 PSI because the steel's not gonna support it, right? It's gonna go to 800, 300,000, and then it's gonna quit, right? It's gonna spread out. It's gonna, the actual, in practice that's a non-linear loading, right? It's not linear elastic, it's a non-linear loading. Now, we might be able to try that, go to some non-linear loadings. I haven't played with the non-linear loadings. Might play with that. Might be interesting to see what it did. I don't actually know if there's an option there. Let's see if there is. That might be fun. I don't think I've ever done one of those. So let's see, let's do a new study and see what the other options are. Thermal bucking fatigue, non-linear. Okay. Static, dynamic. I think static sounds fine. Okay. I've never played with one of these before. Let's go see what we're gonna do. I think I'm gonna go back and, yeah, we'll play with this a little bit, right? We'll put we got a material here. All right. Doesn't take very long. 836. Okay. Now then, the fixtures don't take very long either. All right, we're just gonna go around the back and go U and U. Come on. Why are you not picking it? With that, and I'm gonna go up to the top here, and we'll fix this edge here, and again I'm gonna fix the outer plane one. Okay. Keeps it from moving down, and we'll fix one of these other ones to keep it from shooting off into space. Actually, how about if we pick that one there? No, okay, let's do advanced fixtures, doesn't really matter, and we'll fix this direction here, and I'll also fix the other plane one, just so it gives me some direction there. I like all those, right? We put a load in here. Oops, we gotta go back to the model again. Actually, I do have the coordinate system, don't I? It's already there. Good, bearing, loads. We're gonna put it in there, right? We got a coordinate system, come on. Then you there. I want it in the Y direction, I want it in the opposite direction, and I want 5,000 pounds. Okay. And then we're gonna say that's good there, okay. Okay. Now, let's see what the nonlinear properties are here. All right. Time increment, I don't really want to do it with time. Okay. Yeah, so what it's going to do is it's going to go up to where it's, hopefully, go up to where it's yielding in those places. And that's going to be, okay, now one of the problems I'm going to have is that it's going to be high in those stress constants. I don't have any of the adaptive stuff here in the nonlinear because it's already iterating. So I better put some mesh controls on this. So let's mesh this guy. And I'll go ahead and take their default by definition. And then I'm going to go ahead and put some mesh controls on. So you don't really get necessarily, and I'm going to run them up pretty fine. And I'm going to put mesh controls there, and there, and there, and there, and there. And I run them up pretty fine. I'm actually going to go further than what they've run there. They're getting them only down to like 1/8 of an inch. I'm going to go 0.05 inches. way too many 0.5 inches, and we can see what that does. Okay, and let's see if I can create the mesh. And we can see we've got some finer mesh density in these areas. Don't really have it over on there on the edges, but I have a little bit of a workout there. Let's see what this does when I run it. Never. One of the things you notice is that when you run any of these iterative processes, what is it doing is when on these nonlinear ones, it goes through and loads it, and then goes, well, is it yielding? Yep. And if it hasn't yielded yet, what does it do? It lets it go a little further, right? So we've got a couple spots here that are still above the yielding, but everything is down here is pretty much at the yielding. That's kind of what's expected in these nonlinear results, right? That's what's it doing is it's spreading out. We still have little stress concentrations here, but I'm tempted to ignore them because they're not. What are they actually going to be there in real life? No, they're going to do what? They're going to yield out, right? They're going to yield out. And over here, what's it limited to? Well, it's limited to this thing down here. Right? And so what's it doing is that whenever it gets those stresses, it lets it yield a little bit. And then it spreads that stress out around it, right? It has a nonlinear function. So what it does is it sees something that's like this. It does this, right? Where this is the stress, right? And this is the strain, right? It's making that assumption there, the nonlinear, that it's flat when it's in the yield part of the curve. And as we know from looking at our materials testing, that's pretty darn good assumption, right? Works pretty well, the plastic. So this one, well, a little bit better over there. Actually still got a hot spot down there. I don't really trust it. That's a little bit better, right? Okay. Now, do you think it's going to hold? It's going to fall off the wall. No, I think it'll probably hold, right? How do we know it's going to probably hold? Well, this is yielded, but is it yielding over here? No, it's not yielding over here. So what's this? This is just a little bit of local yielding, right? Right, little bit of local yielding right in those locations there. What's that going to do? That's going to yield in there, right? And then it's going to, right in the stress concentration, it's yielding because it's a stress concentration. What does that do? It spreads the stresses out. And then as long as it's not all plastic, right? It's not it's all plastic, that's where it stops. Because the material yields the first time you load it, and then it doesn't yield anymore. Right? When you let go, it gets compressive, and then when you load it up the next time, it's going to load up to the same place. Right? As long as the load is the same, it's not going to change. Now, if it's a fatigue thing, we got big problems, right? Because it's going to crack right through the welds, but we kind of knew that. We don't like welds for fatigue for this very kind of reason. So that's, yeah, okay. Now, do I have a lot of faith in this? Well, probably more faith than the other one, right? But I still don't have an awful lot of faith in it. Okay? So, and I think I'm going to leave this here with this guy, because if you don't have a lot of faith in welds when you get done with this exercise, I'm not going to be unhappy, because I don't have a lot of faith in these. Okay? They're hard things to model. I mean, it's a simple. Can I come up with a much simpler model for a welded thing? I mean, you got one flat plate, says the thing welded to it, right? I don't think I can come up with a simpler model for something that's welded. And do we weld things all the time? Well, I mean, you can wander off at the Boeing plant, how much stuff is welded up there? Not on the plane, but all the rest of it is, right? So, I mean, there's a lot of, we do welds a lot of things, because it's a great way to make things that are monolithic. Take a bunch of little parts, put them together, and get one big part.
Tubes on the plane.